Yeah. Uh, yeah. So this is what is the as a coordinator I contributed. Uh, I joined this meeting late, but this is quite a need of uh, today's situation, I would like to say. And the whole world seems to be very much um, in need of understanding the climate change. Because of the climate change, our whole life situations are very much at a demanding level, or are we revolving around the our life situations are revolving around the climate change? That is what is the question as a academician nowadays I would like to ask or would like to understand.
Very good. Thank you for this introduction.
Yeah, disaster management is a new subject introduced in our post graduation level. When it was introduced 6 years back, even that time I was not trained for disaster management. Then I underwent a training of disaster management with Central Reserve Police Force for 6 months, and then I become a faculty member. Then I visited the earthquake in Maharashtra, which was in Latur district. So these were the experiences where I work along with my students as a coordinator. But those experiences were life threatening, and coping with those experiences as I was means not equipped mentally, or I will say even physically also. But now I realize that it should be a compulsory subject when it is a optional. So when our students will study the disaster management, and in that the climate change area, I would like to say we as a human beings could able to survive, or we could able to excel by the understanding. This is what is I would like to say. So I like this subject very much from the need identified. Yeah.
Great. Thank you
Right.
so much, Dr.
I very much
Radiative.
agree with you.
Mm.
Yes, those mitigation policies should be known and available to everyone at all levels of schooling. Of course, they must be taught in a certain way to different audience, but we all must, as you say, we must realize the danger of disaster. I like the term disaster when you use, because these subjects must be put in harsh terms so people will stop looking at climate change as a story and will realize it is a fact. It's what's happening around us every day. That's what we must realize. Okay, Ryan, I think it's time to start, I guess, right?
All right, so we have a full house. Thank you so much, Dr. Lozny, so much for coming back. He was the one who opened up the entire course, and he's really excited to talk about climate change. It's a topic that he is really passionate about. He is actually the managing editor of the Journal of Human Ecology. It's an interdisciplinary journal. It's an amazing journal. You guys should all check it out. He's also an archaeologist, an anthropologist, a teacher, a researcher, editor, and has been supporting us at ISL for a pretty long time. And he has been extremely supportive into making all of this happen. So Dr. Lozny has 25 years of academic teaching, research, and cultural resource management experience. He's the author and editor of 8 books. He's the author of 23 chapter books and 17 papers in peer-reviewed journals, and 25 book reviews as well. He presented 23 chapters on academic conferences in the US and in Europe. He has organized 5 international academic sessions and symposia, and he has done huge amounts of work in archaeology, especially in field work, where he supervised phase 1, phase 2, and phase 3 field work. And he's the author, co-author, and contributor to over 100 CRM reports. So thank you so much for coming and supporting ISL throughout the entire process and making this possible. And we thank you so much for coming back. And whenever you're ready, you can begin.
Okay. Thank you very much, Ryan. That was a quite accurate description of my now more than 30 years of academic career. And I may add to this that my recent project and interest relate to climate change and not so much factual evidence, but how indigenous people mitigate climate change. We know how scientists do it, but what is interesting is how people who are not scientists uh, how they react to climate change, and it's quite amazing. I will show you later on that indigenous people have very good understanding of nature and how climate works, understandably because this is what they must know to survive. In modern societies, industrial people, we don't have that sense of significance of climate because we go to grocery store and buy food, and we think this will always be like that. Well, it may not be. It may not be. So this is why we need to focus on climate change and especially on mitigation policies, which I will briefly outline in my presentation today. I want to start with identifying the problem, which is, as we all know, climate change and its adverse effects. I emphasize especially adverse effects because some of those effects are not irreversible. They will not be. We may not. We will never be able, in future generations, will never be able to reverse what happens or what had happened now. And of course, there is a solution to all those climatic problems, and the solution is implementation of local and global policies or policies on local and global scale. But of course, it's easy to say. The question is how to do it and how to convince politicians so they can implement certain rules and policies that scientists have been proposing for many years now, since the 90s, at least as long as I've been doing this, past 30 years. One of my projects that I'm involved recently is illustrated in this picture here in the background, which is from the Kiribati in the South Pacific. This is the several islands, a small community of South Pacific islands. It's a nation, actually. It's a Kiribati is a republic, but if the problem is that some of those islands are going to be flooded soon, and people will have to relocate. They will have to move elsewhere, and will never be able to come back. We have to realize that that is what is the significance of this new ecological environmental problem is all about. People will not be able to come back to the land that they claim as their own, the land of their ancestors. But let's move on. So I approached the policies on climate change at two different levels. One level is the individual actions, which we can address by asking questions. What should we do as individuals? And of course, answer to this question is not as difficult as the answer to the second question, which is the social actions, or I call them collective actions, which relate to the question, what must we do as groups on regional, national, and global scale? So if you want to answer to the first question, well, you may have heard many times what we can do as individuals. Change bulbs in your house and stop using plastic bags, buy electric cars, and instead of gasoline-powered cars, and so on. So these are all individual decisions, but all those individual decisions relate to a bigger question, which is about how groups of people are supposed to behave, what we must do on different social levels, the level of social organization. And of course, I'm interested in this in the second approach. I study groups of people who behave in a certain way, and people who somehow try to address the issue of climate change. They see evidence of climate change, and I'll show you some evidence in a moment. So I organized my presentation in 5 sections. These sections are not well balanced, so to speak, because I pay attention to certain sections and go briefly through other sections. So we'll start with observed changes and causes of climate change, just to introduce the problem. And I think all of you will be familiar with those observed changes and causes. But then I will move on to section 2 and 3, which relate to future climate changes, risks, and impacts, and also future pathways and adoption, mitigation, and sustainable development. I especially emphasize the phrase sustainable development that many people use these days, but may not always realize what it means. The section 4 is the key section in my presentation, which is about adaptation and mitigation. This is especially section on different policies at different level of engagement. And I also have a very brief section limited to 1 slide, which is a socioeconomic impact of climate change. It is just a brief section because I discuss socioeconomic impact also in section 3 and 4, but not directly. And of course, at the end, I'll offer some conclusions about the topic. Before I begin, I must disclose certain information, and that is that most of my information and data come from either my own research or research by others. And in this sense, I used and rely on reports by Intergovernmental Panel on Climate Change, IPCC, abbreviated, which, by the way, also uses some of my research in the reports, especially my research that in the mountains, in the mountain environment, in the Pyrenees. So this is the source of my information, and I think IPCC offered the most authoritative and objective scientific and technical assessment in this field of climate change. It's all very objectivized information. There is no ideology behind what they say. They're very technical reports. All right, so in brief, I'm going to outline very briefly what is the meaning of my presentation, what I intend to do here. So as we all know, aspects of climate change, there are quite wide range of those aspects, but what I'm interested here is direct impacts on climate change, the impacts of climate change on natural systems, and both direct and indirect impacts on human systems. By human systems, I mean human environment, not just individuals, but especially groups of people. And the issues such as human health, food security, and security of social conditions in general. I also consider my presentation in the context of what is known as sustainable development. And I want to briefly outline what I mean by sustainable development. There are 2 conditions that I think are necessary to understand if you want to comprehend sustainable development. One is that it is not possible to draw boundaries around climate change. This is not a section, it's a very complex phenomenon. You cannot just say, I'm interested in climate change, period, and nothing else. Because if you do, you will miss a lot what is the background of climate change, especially the socioeconomic impact of climate change. Now, so we cannot really draw specific boundaries about this issue and associated risks and effects. But the second condition outlines what I mean by sustainable development, and that is developmental designs should meet the needs of the present generation without compromising the ability of future generations to meet their needs. So what it means is that we must envision that what we do today will also impact people in the future. And that is the essence of sustainability, that we must not endanger future generations by making ourselves comfortable. And of course, put it like this, it makes the whole issue even much more difficult to solve. It's not easy. Climate mitigation policies of climate change are not easy, as you will see in a moment. So let's start this presentation. Here are the reasons for concern, why we must be concerned. And I think the key reason is, you can see in this graph here, which shows you the trend of current warming rate. So we are here in 2020. The graph is from 2019, but I think it's very simple to see that this tendency will continue in a straight line. What we must do is to do whatever we can to bend this trend and sort of reverse those adverse effects of climate change, if possible. So climate response uncertainty for 1.5 degrees Celsius must be consistent pathway. This is our goal. If we allow this tendency to continue to about 2 degrees and more than 2 degrees, we are facing catastrophic events. And not in our lifetime, definitely not in my lifetime, but you will see it. And future generations will definitely suffer because of that. So you can see what has been researched until now in the solid line, and the tendency in a dotted line clearly shows what may happen soon within your lifetime, because all of you will see 2040, 2060, and 2080, maybe even the end of the century. So what are the reasons for concern? I have 5 of them here. Unique and threatened systems, ecosystems, environments. But we're going to see more and more extreme weather events, not just heat, but also rain, flooding, which, the extreme heat relates to fires, like we have had in the Western United States a couple of weeks ago. And so on, of flooding, like what they had in Europe a couple of weeks ago, this mudslides, thousands of people affected. Now imagine that this is not going to happen once or twice in a decade, but every year, maybe more than once. That is what is coming. Distribution of impacts, all kinds of impacts. But what I'm concerned about is unequal distribution of impacts. Global aggregate impacts, that's the global scale of climate change. And finally, large-scale singular events. And I don't mean here earthquakes or volcanic eruptions, but large-scale singular events like extended drought, for instance, that would jeopardize our food production tremendously, will increase global migrations for decades to come. So let's review briefly all these 4 sections. So in section 1 is about observed changes and their causes of climate change. So I integrate information on observed changes in a climate system, including changes in the atmosphere, oceans, cryosphere, which is the ice, Arctic areas, and the sea level. I especially discuss present and past drivers affecting climate and review observed causes of climate change. That is very brief review. Before I review those changes and causes, again, another disclaimer here, that the IPCC is now 95% certain that humans are the leading cause of current global warming. So the question is now not who done it. The question now is, what can we do with it? And how fast? And the human influence is evident and growing. There is no discussion about that. But we have the means to limit, not to stop. I want you to understand that we'll not be able to stop climate change, but we have the means to limit climate change and its risks, all kinds of risks. We have certain solutions and new technologies and so on, which I will discuss in other sections. So the goal, the aim here is to stabilize temperature increase to below 2 degrees Celsius, which is relative to pre-industrial levels. And this attempt will require an urgent and fundamental departure from business as usual. That is obvious. There is no question about that. So here's one of the reason why we need to talk about climate change and observe changes in atmosphere, which is now well measured. The graph, this picture here shows you the change, observed change, measured change from 1850 until this is 2010 or 2012 actually. That's the latest data that we have. We're now collecting data from until 2020. I have here some data from 2020, but this is not the point. The point is to see how this line continues, and this is a continued growth. It's going up quite steeply. Here in the map, the globe, you have areas where observable change in surface temperature, and you can see that certain parts of South America, North America, but especially Africa, and look at Asia here, which is the country of Russia. This is the most significant temperature change. If you wonder why we have polar vortex in January and February here, well, part of it is because of this enormous change, temperature change, surface change in Asia. So what we know is that average combined land and ocean surface temperature, which is calculated by a linear trend, show a warming of almost 1 degree Celsius between 1880 and 2012. But for 2020, we have even more drastic numbers because now it's a global average, so it could be locally could be different, a bit higher or lower, but a global average is about 1.76 degrees Fahrenheit, which is 1 degree Celsius, and this is quite the second highest among the years in 1880 well, between 1880 and 2020 record. It is just amazing what sort of change we're observing. To be a little bit more specific, we also observe changes in ocean warming, oceanic waters, which is the largest. I'm concerned mostly about the top 7,500 meters of the oceanic waters, because this is where we fish for food. So this warming oceanic waters within the upper 100 or 75 meters, which by the way, warms up at enormous rate, which is 0.1 degrees Celsius per decade, which means that within 100 years it will be more than 1 degree warmer. But again, you may think it's not much, but it will contribute to enormous change in oceanic waters, especially the water will become more acidic. That means less oxygen. That means less fish. And that's the problem. You can see here in this graph, several independent, 6 independent organizations, institutions, and all those data are very consistent. Independent institutions provided very much consistent research that shows the alarming warming of oceanic waters, especially in the upper levels. But what I'm concerned, I do not study fisheries. Many of my friends do, but I study how humans may respond to rising oceanic waters, and sea level is what I observe for the past decade or so, especially in the South Pacific. This picture is from Kiribati. This is the same picture I used in the opening slide. It is my friend who works in the University of Fiji, Frank Thomas, took this picture a couple of years ago. This is not a very recent picture. Today, the water is coming very close to those houses. And this is not, again, we're not talking about the times of a hurricane or some upsurge. No, this is just steady rise of water table. And what has been observed, the data show that between 1901 and 2010, the global mean sea level rose by about almost 20 centimeters, 1.19 meters. So again, this last 100 years were quite critical, but the water level is rising now faster than throughout the 20th century. The mean rate of global average sea level rise was about 1.7 millimeter a year, almost 2 millimeters a year. And now it has been observed to be 3.2 millimeters a year. That is a really alarming number. But the biggest change, which may not affect people very much, but it will affect climate around the world, is in cryosphere, which is snow and ice around the world. I say biggest change because snow and ice will contribute fresh water to the oceans, and the consequences of large intake of fresh water in salty oceanic waters is catastrophic. If you remember the movie from many years ago, but you may probably still rent it out, the movie was titled "The Day." I'm not remembering anything. The Day After Tomorrow, I think that was the movie in which a climatologist predicted the change in oceanic current, the so-called conveyor belt. And it's the change in this current is significant because now we have the current going from the Gulf of Mexico up to Norway and Scandinavia. That's the Gulf Stream. So it pushes warmer weather all the way from the south north. But if we introduce a lot of sweet water to oceanic salty waters, this conveyor belt may change. And now the water, the cold water will be on top of the ocean and will go from the north south and then turn, and warmer waters will be going back from the Gulf of Mexico, or the southern, not Gulf of Mexico, but southern eastern border of the United States, all the way to Norway and Scandinavia. What this means for us is that this cold water coming from the north will bring also cold air, colder air. We may not freeze to death anytime soon, but we may expect severe changes in climate, severe. This is not happening yet. This is just a scientific fantasy, but it may happen. It may happen. So ironically, climate change may contribute to a new ice age, ironically, which may not be long lasting, but nonetheless, it may happen. So what are the facts here? Well, Greenland, which is in the Arctic, and the Antarctic ice sheets in both poles have been losing mass dramatically. Glaciers have continued to shrink almost worldwide. The same with snow cover. Snow cover is significant because many people rely on snow for fresh water. That's the source of fresh water around the world. And this snow cover is decreasing in an alarming rate. So here I have a picture of, this is the Arctic Sea, which 2 decades ago looked like a solid ice. This was solid ice. Today, it's a patchy ice with a lot of water. So the range of decrease of ice is also quite alarming. It is 3.5 to 4.1% per decade. Again, it may not affect us anytime soon, but us meaning me, people, older people, but you will see the effect of this enormous change in cryosphere. Antarctic ice sheet lost about 2,600 billion tons of ice between 1992 and 2017. That is how much fresh water has been introduced to the oceanic waters, salty waters, and we'll see the consequences of that quite soon. And here's another example of my research used by IPCC in one of the reports, and that is the change in cover snow in this case in the Pyrenees. I observed this sort of it's a snow that turning into a glacier, but the point is that it existed for about 10 years. It's quite a big opening. A human being can stand quite okay here inside this opening, but it disappeared, and by 2009, 2010, it vanished. It didn't exist. No, so it's definitely, and now it's gone. So the snow cover is definitely changing. The elevation here is not very high. It is about 2,000, less than 2,000 meters, about 10,000. Yeah, about 2,000 meters. So it's not a really high elevations, but nonetheless, we can see enormous change in snow cover. The most drastic change is in the decades is from March, April. This is when the time when the snow melts and contributes fresh water to the well-being of the people who rely on it. So 1.6% change for March and April, and up to 11, close to 12% change for June. That, of course, this brings us the question: where do these people get their fresh water from? And the governments work on mitigate this problem, but well, I will see. I'm waiting to see what solutions they have. And of course, the most common observations are about causes. What the causes of past and recent drivers of climate change. So we have, I just showed you what we can observe, what we can see. Now the question is, what is causing all those changes? And of course, there are 2 points that I want to make here. Anthropogenic greenhouse emissions are obvious, the key contributors, but the problem has to be understood in a wider context, and that is economic and population growth. Especially population growth is significant here. If we do not control population growth in a certain way, we're doomed. The same with economic growth. I understand the pressure, and I understand that people want to be rich, but we must ask a serious question: what is the price for that? How much are you willing to pay? And just to illustrate the problem, I have here numbers for concentrations of the 3 most significant greenhouse gases: carbon dioxide, methane, and nitrous oxide. All of them increased tremendously since 1750. This is 1750. The 8th of the 18th century was the time when we got our measurements, the first measurements, not very accurate, but nonetheless, we have data. So we see 40%, 150%, and 20% respectively. That is quite sizable change. Another observed causes are what is called anthropogenic and natural radiative forcing. This is the outcome of our activities and also the activity of the sun. Both have contributed tremendously to global warming recently. Anthropogenic radiative forcing contributed for about 2.3 degrees Celsius. That's what we did. That's our activity, human activity, including carbon dioxide and those other aspects of what do we do and how we do things. Whereas changes in solar irradiance and also volcanic aerosols, they contribute to natural radiative forcing, but not as much. Only around 2% of the total radiative forcing in 2011. That's relative to 1750. I see some background noise. I hear the background noise. Wait with your questions till the end. So what are the future climate changes, risk, and impacts? I will discuss it in more specifically in the second section, but here are some outlines. Human influence has likely contributed to the observed global scale changes and the frequency and intensity of daily temperature extremes since the mid-20th century. What we can see, what you can observe yourself, for instance, if you're not a scientist, you can see that the number of cold days and nights has decreased, and the number of warm days and nights has increased globally. It doesn't matter where you are, what are your climatic conditions. You can see the number, of course, is changing, but the phenomenon is the same. And there is a medium confidence that the observed warming has increased heat-related human mortality and decreased cold-related human mortality in the same regions. So more people die because of heat-related problems. I say medium confidence because that's the phrase I borrowed from IPCC. People are obviously there is no agreement among all the scientists how we should assess the change. So medium confidence means that more or less 50-60% of them would agree with the statement. And I think that's serious enough. All right, so we talked about changes and observable changes and causes. Now let's talk about future climate changes, risk, and impacts. And in this section, I present information about projected changes in the climate system in the 21st century, and also a little bit beyond. I assess future risks and impacts caused by changing climate and the interaction of climate-related and other hazards. So to start this section, I want to emphasize that the increasing magnitudes of warming rise the likelihood of severe, pervasive, and irreversible impacts. So what do we need to understand? Severe, pervasive, and irreversible. For people, all kinds of species of the biosphere will suffer definitely, and the whole ecosystems. Climate change will amplify existing risks and create new risks, which we don't know yet. We can only anticipate those risks, but they're unknown to us. And the problem with risk is that they are unevenly distributed. Unevenly distributed create a severe socioeconomic problem. That's the socioeconomic aspect of this climate change. Because if climate change affects all of us, that's true, but not all of us will feel its effect the same way. Especially people in countries underdeveloped with no capacity to implement new technologies or answers to climatic change. So those high emissions of greenhouse gases that I mentioned earlier would lead to primarily adverse effects on biodiversity, ecosystem services, many people rely on that around the world, and economic development and as well, and also amplify livelihoods, food, and human security risks. I emphasize the issue of food security, which is critical, not to all of us, not just people who produce their foods, but also people who buy foodstuffs in grocery stores. Don't be surprised if you see prices for basic foodstuffs such as bread and milk going up tremendously. But I also see specific areas of risk that should be mitigated somehow. And I identified 4 such areas. The first one is the risk of severe ill health problems resulting from storm surges, sea level rise, coastal flooding, inland flooding, and some urban regions and periods of extreme heat, which includes deaths. So ill health and disrupted livelihoods, that's the big problem. The second group of problems or risks will be systemic risk due to extreme weather events. Though those risks will be permanent, leading to infrastructure networks and critical services breakdowns, such as outages, for instance. No electricity, not for a couple of hours, but a couple of days or weeks. Can you imagine if you have no electricity for a couple of days? And the entire economy will crumble. The second group of risk will be risk of food and water insecurity and loss of rural livelihoods and income. This group of risks apply especially to impoverished populations, Africa, Southeastern Asia, such regions. And finally, the group of risks that apply to all of us: the risk of loss of ecosystems, biodiversity, ecosystems, goods and functions, and services. So these are the most significant, in my view, sectors of risks. And the future doesn't look promising. It actually looks quite bleak, in my view, because many aspects of climate change will continue for centuries. Even if we stop or limit anthropogenic emissions and greenhouse gases, those effects will continue. The risks are abrupt and irreversible, and future generations supposed to. That's what I meant earlier when I discussed sustainability. They're supposed to somehow adapt to these new changes, new realities that we have created for them. So, quite a sizable fraction of anthropogenic climate change, especially resulting from CO2 emissions, is irreversible on multi-century, even millennial time scale. Which again, you can say, why should we care today? Well, we don't have to care because it won't affect us, but that's a legacy we're going to leave to future generations. All right, so that's enough of scary things. Let's talk about what I identify as section 3, which is future pathways for adoption, mitigation, and sustainable development. I especially emphasize sustainable development here. So I address future pathways for adoption and mitigation as complementary strategies for reducing and managing climate risk and assessing their interaction with sustainable development. I try to describe conditions for effective decision-making and differences in the risk of climate change, adaptation of different policies, and mitigation of effects in terms of timescale, magnitude, and persistence. Finally, I will briefly analyze the characteristics of adaptation and mitigation pathways and associated challenges, limits, and benefits, including different levels of future warming. So as I mentioned, adoption and mitigation are complementary strategies. So we have to adopt certain technologies or policies to create effective strategy for reducing and managing the risk of climate change. And substantial emissions reductions must happen if we want to reduce climate risk in the 21st century and beyond. Successful strategies will rely on specific decision-making. Decision-making are essential here, especially decision-making based on scientific evidence, scientific data, not just visions. So those foundations of decision-making are quite essential. Effective decision-making to limit climate change and its effect can be informed by a wide range of analytical approaches for evaluating expected risk and benefits, recognizing the importance of governance, ethical dimensions, equity, value judgments, economic assessments, and diverse perception and responses to risk and uncertainty. I especially emphasize here importance of governance, all levels of governance, from local to global. Oh, there is no global governance yet, but it's becoming. It's coming soon. I also want to point out the ethical dimensions, which are almost always overlooked. Nobody talks about the ethics. Yeah, equity. We discuss equities today, and so it's a common issue. But I also want to point out that effective mitigation will not be achieved if individual agents advance their interests independently. What I'm saying here is that there is no government in the world that can address climate change issues itself. There must be a collective effort. Otherwise, all mitigation strategies will not be effective. People will do something, will try to do something, but will not succeed. So adaptation planning and implementation must be based on certain very specific approach, and that is complementary actions across levels, from individual to governments. And such actions will enhance adaptation planning and implementation of policies. Complementary actions. National governments play a critical role here because they have the power, the means, and they can coordinate adoption efforts of local and subnational governments, for example, by protecting vulnerable people, by supporting economic diversification, which is quite essential, and also by providing information, policy, and legal frameworks, and also, don't forget, financial support. So local governments and the private sector are both significant agents in adaptation. They both contribute to adaptation, to success of those strategies. So how this can be done? This is a little bit of my vision, how those policies they're supposed to be approached. So the first step towards adaptation to future climate change is reducing vulnerability and exposure to present climate variability. This is strictly decision-making issue. Integration of adaptation into planning, that's the governmental responsibility, including policy design and decision-making, can promote synergies with development and disaster risk reduction. So it has to be a coherent, well-organized activity. We cannot have agencies working independently. They must create a network of activities. Why? Because poor planning or implementation, overemphasizing short-term outcomes, and many governments do that, or failing to anticipate consequences sufficiently, can result in maladaptation, increasing the vulnerability or exposure of the target groups in the future, or the vulnerability of other people, places, and sectors. We cannot allow that. Especially, what I mean by poor planning is that, again, governments have their own priorities, and so they plan how to do things. But if they do not coordinate their planning with other governments, other regions, that's what I consider poor planning. You cannot emphasize your private, your individual priorities and pursue them, irregardless what other neighboring regions or other countries are doing. For example, this is one of the most common problem. Enhanced protection of exposed assets can lock in dependence on future protection measures. We know this happened in the past. It is happening in some countries today. And well, we don't want to have this problem as perpetual problem. We want to get rid of it. So adaptation and mitigation experience accumulate across the regions and scales. This is where we draw our experience from. This is how we learn. And it's a very good, successful learning. Adaptation is becoming embedded in some planning processes. People, governments and agencies must realize that. You know, for instance, there is a big discussion these days going on what to do with coal mines. Coal mining is a big part of local economies, but can we close them down? Well, we should, obviously, but it has to be a plan. You cannot go and say to local governments or shut it down because you're polluting the atmosphere. It has to be done in a certain way. Now, it has been done in France, for instance. The French government closed down the coal mines back in the 80s and early 90s. There is not even one existing functioning coal mine in France. The same happened in England, Great Britain. It's not happening in the United States. It's not happening in China. It's not happening in Russia. And those are big polluters of the atmosphere. But there is a certain positive aspect because governments at various levels have begun to develop adaptation plans and policies to integrate climate change considerations into broader development plans. Those governments act the way they're supposed to. I just only wish that more governments should be responsible like that. One of the government I want to point out, which has, I think, in my view, the best response policies is the Philippines, the government of the Philippines. A model approach how to deal with climate change issues. Here's some factual data about the characteristics of mitigation pathways. Well, I say factual because they're based on certain numbers, but what I'm presenting here in this graph, especially, is a certain vision. As you can see, there are multiple pathways, but number 1 and 2 are perhaps the best options. 3 and 4, but 3 is still acceptable. 4 is overshooting the outcome. So this is the ideal situation, that we limit the number of tons of CO2 emissions a year from what we have now, about 40, in some cases more than 40 billion tons, to about 0 by the year 2000. Well, 0 maybe not 2050, but sometime between 2050 and 60. And then the tendency will continue until the end of the century, which is the ideal situation. I don't expect this to happen, but we should get close to what we see here on this graph. This is if we want to keep the warming below 2 degrees Celsius globally. It is doable, but it's not easy, and that's the problem. Here's another scenario of mitigation pathways, how we can approach this to limit the warming below 2 degrees Celsius. And if you look at this graph here, it's possible to do it by 2050, but it will take drastic measures. So greenhouse gases emissions, which are very high, this is 2020 right here, very high. If we introduce those mitigation pathways that I mentioned earlier, we have a chance to limit, maybe not up to 0 net, but quite low by those emissions by 2050. But at the same time, we have to invest in carbon removal technology, so carbon capture and storage technologies, which is quite costly investment. But I want to emphasize that there are new forms of energy available. This is what we have to invest in. Renewable energy, nuclear energy, and we can still use fossil energy, but with carbon dioxide capture and storage technology. That is the option, which is available, but expensive, quite expensive. Nuclear energy has its drawbacks, as we know, especially when it comes to security. Renewable energy must be the best option for now. All those windmills that you can see around and so on. That's a good option, but it's an option to fix the problem briefly, but it's not a long-term option. Our consumption of energy is much higher than what windmills and solar panels may produce. But that's the cheapest and fastest option for now. Now, my research includes a certain adaptation planning and implementation that includes all groups of people, especially indigenous people. Here in these pictures, I have these are pictures from a friend of mine, Professor Karim Ali Kassam from Cornell University, who is pictured here and in here. And what he does is he investigates indigenous people responses to climate change. Indigenous people have an obvious interest in climate change because their livelihood depends on what sort of climate they live in. So they mitigate those effects quite nicely and effectively. Here you have, in the first picture, you have a group of elders. These are the elders from, I think, Tajikistan, if I remember correctly. So there's a conference now with the scientists from Cornell and local elders, how to approach those problems caused by climate change. The second picture here is actually quite interesting. This is from 1999, some time ago, almost 30 years ago. And you have this is from the Arctic, way up in the Inuit land, and you have an Inuit person here explaining in a very scientific terms. It's quite extraordinary. In a very scientific term, explaining what he and his people observed for decades in the Arctic. And they contribute their local knowledge, their knowledge on climate change to scientists who now may synthesize. The idea is to synthesize these two knowledges, indigenous knowledge and scientific knowledge, into comprehensive response mitigation policy. In both cases, I must say, Karima, Dr. Karima Kassam was quite successful. I'm going to a conference near Cornell in October, where we'll be reporting on the most recent outcomes of the research. Okay, and this brings us to the final section of my presentation, which will be almost entirely on policies, different policies. Policies that relate to adaptation and mitigation of those adverse effects of climate change. So here I bring together information on specific adaptation and mitigation options, including environmentally sound technologies and infrastructure, sustainable livelihoods, behavior, and lifestyle choices. I want to emphasize lifestyle choices are quite critical. This is what we can do as individuals and also as groups. One of the lifestyle choices is, for instance, tourism, travel. I know people like to travel, but we have to realize that travel is one of the contributors, and quite significant contributors, to local ecological change. I'm not saying we must limit travel, but we have to plan travel more carefully. And maybe that might include limiting travel as well. So I describe common enabling factors and constraints and policy approaches, finance and technology on which effective response measures depend. I also show opportunities for integrated responses and links, adaptation and mitigation with other societal objectives. So to introduce those mitigation policies, I have to say that we have many options that can help address climate change. However, not one single option is sufficient by itself. So even if we limit or stop emissions, it will be a good contribution, but it will not stop the phenomenon. It will affect the phenomenon, but it will not stop it. So effective implementation depends on policies and cooperation at all scales and can be enhanced through integrated responses that link mitigation and adaptation with other societal objectives. I think the key word here is cooperation. That is what my research shows is essential in achieving those goals. Among the common enabling factors that underpin adaptation and mitigation responses, we have institutions and governance, innovation and investments in environmentally sound technologies, especially those carbon capturing technologies and infrastructure as well. Sustainable livelihoods and behavioral and lifestyle choices. Again, I point out to the last one, behavioral and lifestyle choices. This is what we can do as individuals. And don't think that if I change something, it doesn't matter because, it's just one person. That's not wrong thinking. If we all do the same, or not the same, but we all engage in behavioral and lifestyle choices, changes in those choices, we will definitely contribute something significant. Just one simple example, like, stop using plastic bags, use reusable bags for shopping, for storing, and so on. Plastic is the key problem now, as far as environmental pollution is concerned. Innovation and change is essential. Not all governments may be allowed to do that because of obvious economic constraints, but innovation and change will definitely be significant and can expand availability and effectiveness of adaptation and mitigation options. And in the same way, similarly, new technologies and infrastructure can so richer countries, richer governments, and including private institutions, World Bank, for instance, IMF, may contribute here to introducing and making those technologies and infrastructure changes available. Investment in technology and infrastructure rely on enabling policy environment, access to finance and technology, and a broader economic development that builds capacity.